I'm the Math 1121 SI instructor for today. Today I'll be going over sections 5.1 through 10.2, working a few problems from the homework set off of Moodle. I'm going to start with section 5.1. Number 9. And this is, they're just taking the antiderivative of 5 halves x to the 3 halves. And I work this, both methods. First method is here, second method here. Do this one in red. First method, we're looking for K. We want to write all the information that we know that was given to us. We're looking for K. We're going to let U equal X. N minus 1 equals 3 halves, which means N equals 3 halves plus 1 plus 1, which is 5 halves. We're looking for K. You got U. Okay. Now write the problem in this form. K, N, 5 halves. This should be N minus 1. This should be, excuse me, K, N, U, N minus 1, U prime, or derivative of U. K, N, U is X, N minus 1 is 3 halves, U prime, which doesn't apply. All this equals the original function, and solve for K. Five x to the 3 halves cancels. K equals 1. Rewrite the formula like this. K, U to the 5 halves, or x to the 5 halves. Next, I'll solve it with the second method, U n plus 1 over n plus 1. U equals x. This time, for this method, they give you n instead of n minus 1. So n equals 3 halves. N plus 1. N plus 1 equals 3 halves plus 1 equals 5 halves. And just take U n plus 1 over n plus 1. And then we got the 5 halves that we took out. X to the 5 halves. Antiderivative. That completes section 5.1. We'll move to section 5.2. This is indefinite integrals. Keep my equations up. section 5.2. Number 1, integrate 2x dx. This is an indefinite integral. We want to take the antiderivative of 2x. So we can use either method. I'll solve in both methods again. Start with method 1. Method 1, you're looking for k. U equals x. N minus 1 equals 1, which means n equals 2. Write it in this form, k, n, u to the n minus 1, u prime, which doesn't apply, equals the original function. These cancels, k equals 1. Write it like this time. 1 x to the n, which is 2, or x squared. Since it's an indefinite integral, there's no a and b limits, so it's plus c, which is that constant. Second method, use this equation. U equals x, n equals 1, n plus 1 equals 2. And I solve x to the 1 plus 1 over x over 2, which is x squared over 2. But don't forget that constant you took out. So 2x squared over 2 or x squared plus c, since it's indefinite integral. And that concludes section 5.2. Moving on to section 5.4. Section 5.4. Number 1, definite integrals. They want us to integrate the same thing. Matter of fact, I'll do another one since that's the same, almost the same problem as section 5.2. So I'm gonna do number 3. Integrate for x to the 5 halves dx. Again, I'll take the antiderivative of x to the 5 halves. I'll do both methods. And I got a boundary in between 1 and 4. Looking for k. U equals x, n minus 1 equals 5 halves, n equals 5 halves plus 1 equals 7 halves. Write it in this form. K, n is 7 halves, U is x to the 5 halves. U prime doesn't apply. Equals x to the 5 halves. X to the 5 halves. X to the 5 halves cancel. So 7 halves k equals 1. Or k equals 2/7. Write it back like this. 2/7. U is x. N equals 7 halves. In between 4 and 1. So now we plug the 4 and the 1 limits on this. Equals the area. Calculator. Put your antiderivative in, 2/7 x to the 7 halves, graph. Second cap, value. You want to know the values of 4 and 1. 4 is 36.574 minus 1.2857. That equals 36.2883. Or 254 divided by 7. 254 divided by 7. Yep. The other method, we'll use n plus 1 over n plus 1. X equals U equals X. N equals 5 halves. N plus 1 equals 5 halves plus 1 equals 7 halves. X to the 7 halves. Can't see that. 7 halves over 7 halves, or x to the 7 halves, 2 over 7. That's the same thing we got right here. Plug the values back in the same way we just did on the calculator, and you should get the same thing when you plug that in. This is an easier method when you don't have to use the chain rule. And that completes section 5.4. Moving on to 6.2. Section 6.2. Number 1. Y equals 4x. Boundaries are y equals 0 and x equals 1. So first thing we want to do is graph the function y equals 4x. 4x. Looks something like this. Then our boundaries are y equals 0, which is this, and x equals 1, which will be around somewhere here, depending on the scale. I should actually keep going. Okay, we want to find the area of this enclosed section. We want to find the area of that. So we can use the vertical line rule, which means we will sum all the areas of the vertical line across the x-axis in between that section. You could do it by integrating the difference between the top and bottom function, y equals 4x and y equals 0. The boundary, first, fx minus 0, top minus the bottom, and the boundaries are x equals 1 and 0. This is where they intersect right here. dx. Differential and the differential across x. This can be written or changing x. So we write this 4x dx. Take the antiderivative. This time I'm only going to use this method. Separate the 4x. U equals x, n equals 1, n plus 1 equals 2. So it'll be x to the second over 2. Two cancel, you got 2x squared the area equals put the antiderivative in and graph it, and then solve for f of 1, which is the antiderivative of that function, the capital F. Plug 1 in. Two, area equals 2 minus zero. Area equals 2 units squared. For this section of 6.2, I'll do one more with the horizontal test. Number 11 says y equals square root of x. Or y equals x to the 1/2. I'm going to use this method to, no, first I need to graph the function. Square root of x. It looks something like this. Forgot to write my boundaries. My boundaries are x equals 0, y equals 1, and y equals 3. X equals 0 is right here. Y equals 3. Right here, you could tell where y falls on the function by the table in your calculator. If y equals 3, then x equals 9. So this is 3, 9. And y equals 1, which is right here somewhere. Yep. Okay. Now that we want to find the area in these boundaries, which is right here. It couldn't be this boundary because it doesn't close. It just keeps going. So, excuse me. So we want to find the area of this, find the area of this area, units squared. So we can use the vertical line test for this one. We can't use the vertical line test for this one. We have to go horizontal and sum the areas across the y-axis, which means we also have to rotate our axis or solve for y instead of x, which means y equals x to the 1/2 needs to be solved for x. So to do that, I can square both sides, and it'll be y squared equals x. So we would take the derivative. No, we set up a. That's our function. We need to find the area right there. Our boundaries are 3 and 1. And you're taking high minus low, or the right function minus the left function, if you're looking at it this way. So this this square root of x function minus this boundary y equals 3. And instead of dy, it's dx. Instead of dx, it's dy, because it's the change in y, not the change in x that you're looking for the area. Y squared minus, excuse me. We need to put it in here in terms of y. So it'll be y squared. Solve this, y equals 3. X is 0 minus 0. Because this is not x to the, it's y squared now. And this one is x is 0. See why it's not 3 though. That top boundary is 3. I think it's 3 right here. He has 0. Because the x is at a 0. X equals, x is 0 in this. And this one, y, x equals y halves, x equals 0, dy. And then just take the antiderivative. 3, 1, y squared, dy. Antiderivative, y cubed over 1/3. Area equals, put the antiderivative in your calculator. 1 divided by 3. You can put x for y. Graph it. F of 3 equals 9. F of 1 equals 1/3 minus 1/3. 9 minus 1/3, 8 2/3 units squared. And that should complete section 6.2. Next section, 6.6, but it's not going to be on the exam. So, move to 10.2, which is integration by substitution. So section 10.2, number 3, they want you to integrate x 2x plus 1 dx. This is indefinite integration by substitution. So always put plus c at the end. Dx. And now substitution. We'll start substitution. Let u equal 2x plus 1 to the 1/2. Then solve for x. You want to solve for x. So u squared equals 2x plus 1. And then x equals u squared minus 1 equals 2x. U squared minus 1 over 2 equals x. And then you want the antiderivative of x. Rewrite x. That can be written like this. Take the derivative of x, which is x prime equals 1/2 to u to u. X prime equals u. X prime equals u. Du. Okay. Now that we have all our variables, we will substitute back in. Integrate x. Substitute x in. 2x plus 1 to the 1/2. That's u. And dx, derivative of x, right here. U du. So we got x 2x plus 1, which is u, and then all this is x. 1/2 u squared. That's u. And then dx is u du. And just simplify. that can become u squared. So 1/2 u squared minus 1 u squared. 1/2 u to the 4th minus u squared. Du, I think I took the du out. I'm gonna make some more room right here. We have 1/2 u to the 4th minus u squared du. And then we solve for it. I didn't put the integral up here. Antiderivative. I'm gonna rewrite this. Take the antiderivative of this, all this, which is 1/2. Let me erase this form. 1/2 u to the 5th over 5 minus 1/2 u to the 3rd over 3. What's this equal? So dx equals u du. X equals 1/2 u squared minus 1. U squared equals 2x plus 1. U equals 2x plus 1 to the 1/2. I can erase this one, this one, 1/2 square 1. Erase this. Got u squared up there. Got u up there. And I ended up with 1/2 u to the 5th over 5 minus 1/2 u to the 3rd over 3. Equals the area. What are we looking for? Doesn't tell us. Simplify. That's 10. Now we simplified and we took the antiderivative, we integrated with u in there. We need to substitute our x back in for u. So I'll get rid of all this. Substitute x back in, so u equals 2x plus 1 to the 1/2. But we got u to the 5th, so we just put a 5 in there instead of a 1. So u to the 5th is 2x plus 1 to the 5 halves over 10 minus u to the 3 halves over 6 plus c. And what we got? Yep. This answer, he says in his notes, this answer is good enough. You can simplify, but this is all he wants to see you know how to do. And that concludes section 10.2. That concludes our SI session for today. Review for the exam and the last exam. Definite and indefinite integrals. Most of the work is antiderivatives. Once you have that down, it's all plug and chug from there. But that concludes our session for today. Thank you for watching, and I'll see you next week.